This is going to be a two-part video. In this first video, I'm going to go over sound design, and then in the second video, I'm going to make another Chronos effects tutorial. So in this one, I'm going to focus on something called modal synthesis. That I'm getting this idea from this guy, Cameron, who goes by Venus Theory. He's super popular on YouTube. I don't know why he calls it modal synthesis. I would just call this physical modeling because that's what we're going to be doing, except we're going to be using AL1 instead of STR1. So let's jump right into it. I'm going to start off with just a single EXI, and I'm going to be using bandpass filters in AL1, and I want to make sure that the first bandpass filters are in tune. At least the very first one should be in tune. As far as what you do with the rest, it doesn't really matter. So I'll choose two bandpass filters. I'm going to turn their resonance all the way up, so we're going to end up using these as like resonant filters. The filters in AL1 do not self-oscillate, but you will notice that with the reso base parameter, there is a kind of feedback effect, and we'll get into that much later in this tutorial. So let's set the frequency to the first one. Actually, let me jump back to oscillator pitch and route to both filters. So let's check where our fundamental is at in this sawtooth wave, and you'll notice that 30 nails the fundamental. And then if I want to set the second filter to be the first harmonic, every 10 increments of the filter frequency value is an octave. So I know that on 40, I'll be hitting the second harmonic perfectly, and I'll take down the level of the second one. And I also want to just use noise at this point because I only wanted to use an oscillator just to be able to set the tuning. And also the filters by default are key tracked, and that is for both filters, so we can like play the filters with key tracking. And for the mixer, I do want to route the noise to both filters as well, which is why we're only seeing one harmonic there for a second, but now we'll see two harmonics. You'll notice that the sound is pretty quiet. If I want to remedy that, I could just throw it through a compressor. Just use the regular stereodynamic compressor. I'll turn it on, and hopefully that's enough volume for you. And in the filter section, I do want to make sure that that second harmonic, you don't really have to do this, but I do want to make sure that it's lower than the first, so our fundamental really really sticks out. That's without it. That to me sounds nice right there. And let's do the same thing for EXI2, which will be another instance of AL1. And let's go into EXI2, take down our oscillators. We'll just use noise. And for our filters, we'll go with a parallel configuration. Real fast, let's set our balance to go into both filters. And for those filters, we will be choosing band passes at full resonance for each. There we go. And I'm just going to set these by ear. I don't really want these to be harmonic. I want them to be inharmonic, because by doing so, it ends up making it so the sound sounds more like metallic or woody. It just makes it like more of a percussive sound, which is what I'm going to kind of be going for here. So let's just set these. Reminds me of like the wolf howling from Twilight Princess. It's probably fine right there. Let's set the next one. That's nice. Let's try playing that. Now, something cool about this is that since we have individual control of each partial, we can not only set the levels individually, but we could even set the panning per partial. And yeah, of course the frequency, and you know, it's kind of fun tricks like that that makes this pretty neat. So this doesn't quite sound like physical modeling, and that's because what I'm going to call our excitation source, our noise, is constant. So I don't want that. I want to take the noise all the way down. I'm going to modulate it via EG1. I'll do the same thing for our EXI2. Take it all the way down, modulate it via EG1, and that's going to be with full modulation intensity for each. Let's go over into our envelope generators and take down the the break and sustain, because I just want a quick pluck sound. If you're doing this on the Kronos itself, you can just end up copying your envelope generator parameters from one EXI to the other. But since I'm using the editor, I have to do it manually. I technically could do it on the Kronos and just send the data here, but you wouldn't get to see it. So I want my decay to be super short. 16 is probably fine. Let's do that for both envelopes. And now when I hit a key, it sounds more metallic. And it's pretty quiet. Let me turn that up via our compressor. So let's slide around the partials a bit on the second one. That sounds pretty good. It's kind of like a plinky sound. Let's turn up the amp drive for each. Now here's something that's really interesting. What I mentioned earlier in the video is that we can actually change the reso bass parameter to full, and that'll add more sustain to the sound. And we'll do that for all filters. So isn't that interesting how that quick impulse now has more sustain because of this parameter right here. If I were to take that off, for instance, this filter A is for the first harmonic. See how quickly it goes away? But then with reso bass on full, see that it sustains. Now I want the release to be a little bit longer. Let's turn that on like 40, sure. And turning it up on the amp envelope alone, I believe should be sufficient. Yep, that has a better response than it just simply gating off suddenly when releasing the note. I could also turn up the sustain, but since this is a percussive sound, this is the default's fine for now. So the last thing that I want to go into is that if we wanted to add unison to the sound, we kind of couldn't do it because we're utilizing filter position and noise for the sound. So adding unison will simply raise the volume of the sound, but detuning won't do anything because you can't detune noise, and detuning doesn't have an effect on the filter cutoff position. We could use stereo spread, but it doesn't really matter in this case, besides I'm recording in mono. In the next video I'll record in stereo. But yeah, we do raise the number of... all we do effectively with unison is raise the volume, but if I want to create width other than panning the partials directly, I would have to use an effect like the 6-tap chorus delay unit in the Kronos, which is what the next tutorial will be on, and that will obviously create width in whatever you throw in it, because it's just a matter of modulating the delay lines that make up that effect. So I'll get into that in the next video, and for this one we're going to call it quits.